A ratio is a comparison of two numbers by division. We have something called a part-to-part ratio and a part-to-whole. So a part-to-part and a part-to-whole. There are 3 different ways to write a ratio. We can write a ratio as a fraction. We can use a colon. And let's see what a colon looks like. So those are just 2 dots, one on top of the other. Kind of what you see when you're looking at the time, like what time it is. We have that colon. So using a colon between the comparisons and using the word to. So there are 3 different ways to write a ratio. As a fraction, using a colon between the comparisons, and using the word to. For example, if there are 3 boys and 2 girls standing in line for a snack, you can write it as 3 over 2, or 3 seconds. You see it as a fraction there. You can write it using the colon, 3 colon 2, but you would still read that as 3 to 2. Or you can use the word to, 3 to 2. So those are 3 ways that you can show the ratio. Ratio language is using words to show a ratio relationship. For example, for blank 3 boys standing in line, there are 2 girls. What word do you think goes in the blank? For every 3 boys standing in line, there are 2 girls. This is comparing a blank to blank. This is comparing a part to part. So you have the 3 boys to the 2 girls. That's each one is representing a part of the group. The boys and the girls, they're each a part of the group. So that's a part-to-part relationship. A part-to-whole would be comparing a part to the total amount in the group. For example, for every 3 boys, there are 5 total students. Because if you have the 3 boys and the 2 girls, there's 5 total students. So if you're comparing one of the parts to the whole group, that's a part-to-whole ratio. So boys to the total students is 3 to 5, and the 3 is the 3 boys, and the 5 is the boys plus the girls, because there's 5 students. Order matters. That's really important. You cannot switch the numerator and denominator on the ratio. Order matters. So for example, if you were supposed to write the ratio of boys to girls and you wrote 2 to 3, that would be incorrect, because you're basically then saying the 2 is representing the boys and the 3 is representing the girls, and that's not true. There's 3 boys and there's 2 girls. You have to write the ratio in the order that it's stated in the problem. You have to write it in the order that it's stated in the problem. So let's look at this example. How many bananas are there to monkeys? So we're comparing bananas to monkeys. So bananas to monkeys. So there are 3 forms. So in that table right there, we're going to write down the 3 forms. Well, the first thing that was listed was bananas. So we need to write the number that represents bananas. There are 5 bananas. If you count them, you'll see 5 bananas there. So we're going to write it using a fraction first. So we're going to put a 5 as our numerator over, and then the second item we're comparing is the monkeys. Well, how many monkeys are there? There's 4. So we're going to put 4 as our denominator. So it's going to be 5 over 4 or 5/4. That's the first form we can write it. Now let's write it using a colon. So keeping it in that same order, it's 5:4, but we still read that as 5 to 4. We don't say 5:4. I only said colon to stress that we're using that symbol. So 5 to 4. And then we can use the word to, T-O. So we're going to keep it in the same order. Remember, order matters. So we're going to write it as 5 to 4. 5 to 4. Those are our 3 forms. Now let's use ratio language. We can say for every 5 bananas, there are 4 monkeys. So let's write that down. So we're going to say for every 5 bananas, there are 4 monkeys. What type of ratio is this? Is this a part to part or a part to whole? Well, we need to ask ourselves, are bananas part of the whole group? Yes. Are monkeys part of the whole group? Yes. So that means it's a part to part relationship. So we're going to write part to part. Okay, the next question asks, how many cookies are there to total desserts? Well, you look at the table to the left there, and it has desserts, and the different desserts are ice cream, cookies, and brownies. So we're comparing cookies to total desserts. So I'm going to highlight what it is that we're comparing. We're comparing cookies to total desserts. So I need to look to see how many cookies are there. The amount of cookies that it's stated in the table is 9. So that's going to be my first value I'm going to use for my ratio. And the first form we're going to do is a fraction. So we're going to do 9 to the total. Well, it asks for the total desserts. So we need to count how many total desserts are there. So to count the total desserts, you need to add up all of those desserts. So you have 11 plus 9, and that's 20. And 20 plus 6 is 26. So that's 9 over 26, or 9/26. The second way we can write that ratio is using the colon. So we're going to put 9, then the colon, and 26. But remember, we still read that as 9 to 26. The next form is using the word to. So we're going to say 9 to 26. Could I put 26 to 9? No, because it doesn't say total desserts to cookies. It says cookies to total desserts. Order matters. You write it the way that it's described in the problem. Let's use ratio language now. So we're going to say for every 9 cookies, there are 26 total desserts. So let's write that down. For every 9 cookies, there are 26 total desserts. Okay, let's go ahead and. So what type of ratio is this? Well, The cookies, that's a part of the whole. Then it says total desserts. That's the entire group of desserts. So this is a part to whole. So we're going to write that down. Part to whole. Okay, so here we go. What is the ratio of triangles to rectangles? Well, we need to count how many triangles are there. And there's 9. So that is going to be the first number represented in our ratio. So 9 over, we're going to write a fraction. And how many rectangles are there? 3. That is an improper fraction, but that's how we need to write it because it's comparing triangles to rectangles, not rectangles to triangles. So 9 over 3. The second form, remember, is using a colon. So 9 colon 3, or we would say 9 to 3. And then the third form is using that word 2, 9 to 3. Ratio language. So we start with the triangles, then the rectangles. So we'll say for every 9 triangles, there are 3 rectangles. So let's write that down. For every 9 triangles, there are 3 rectangles. Okay, the type of ratio this is, well, it's comparing triangles to rectangles. Triangles is part of the whole group. Rectangles is part of the whole group. So that means this is a part to part ratio. So let's write down part to part. The next one is wanting to compare ovals to total shapes. Okay, well, let's count how many ovals there are. There are 6. So we're going to use a fraction for the first one. So it's going to be 6 over. And this is total. So that means we need to add them all together. Well, there's 3 rectangles. There's 9 triangles. And there's 6 ovals. So we're going to add all those together. 9 plus 3 is 12. And 12 plus 6 is 18. So it's 6 over 18. Now, some of you might be thinking this is not simplified, and we could definitely simplify this. Tomorrow in our lesson, we're going to be focusing on simplifying our ratios. So for now, we'll just leave it as it is. So actually, I want us to go ahead and simplify it after all. We're going to use the identity property to simplify it. So we're going to divide, and then go ahead and make your number 1. And your little fraction bar inside. What's the greatest common factor of 6 and 18? What can go both into 6 and 18? 6. So we're going to put 6 as our numerator, 6 as our denominator. 6 divided by 6 is 1, and 18 divided by 6 is 3. So it's 1 over 3, 1/3. That's equivalent to 6/18. Now let's use the colon, 1 to 3, and 1 2, 3. That gives us a head start for our lesson tomorrow. Okay, using ratio language, we're going to use the simplified ratio. So we're going to say for every 1 oval, there are 3 total shapes. For this simplified fraction, I don't care for it too much because there really isn't a total of 3. That's only if there was only 1 oval, really. So it's kind of misconstruing the total amount of shapes there. So we could even say for this particular one, for every 6 ovals, there are a total of 18 shapes. What type of ratio is this? Well, it's comparing a part to the whole group. So it's going to be a part to whole. So this is a part to whole. Part to whole. today I learned that a ratio is a comparison of two numbers by division, part to part and part to whole. There are three different ways to write a ratio: as a fraction, using a colon between the comparisons, and using the word to.